Hi, welcome to this video. It's for Leetcode 543, diameter of a binary tree. I actually recorded this video earlier, but I forgot to hit the record button, and I am recording it one more time. This is a particular problem that uses a technique of our favorite, DFS, depth first search. So for this problem, it asks you to find the length of the longest path between any two nodes in a tree. And so it also says this path may or may not pass through the root. So let's take a look really quickly at what we're dealing with here. So you get a tree like this, and which parts of it qualify for the longest path? Well, all of it in this case. And all of it contains 4 nodes, and every time you want to find out the longest path, you figure out how many nodes are in there, and then you subtract 1 and you get the length of those nodes, which will be the diameter. So let's take a look at an example. If you only have 1 node, then the diameter would actually be 0. Because you have 1 node, we mentioned you take the number of nodes in that path, subtract 1. Now, what if you have more than 1 node? What if you have 2 nodes? Well, same idea. Take the number of nodes, subtract 1, give you the diameter, right? Your nodes are here, here, 2 nodes, the diameter is just right there. Let's take a look at another example. Alright, so you should also know that, for example, R1, 2, 3, 4, your answer could be coming down this way, 1, 2, or 1 to 2 and 2 to 4. Answer is still going to be 2. It's just that your code won't distinguish whether it cares that you went down this left path or this right path. Okay? Now, let's look at the code really fast. I consider this to be a utility problem where there is not a lot of coding involved because it's using recursion. And if you're doing a phone screen on the computer through some code sharing platform like CoderPad, if you're getting 45 minutes to talk to somebody, this might be problem number 1. And after you solve this really quickly, you might get problem number 2, which might be medium or hard. It just depends. Now, a really quick walkthrough. In the outer function, you keep the global variable for answer, and then you have your DFS here. So outer function is the runner that calls DFS, right? Now DFS, what happens? If you do not see any value for the node, you return 0. Then you find the value of the left one. You recurse left, recurse right. After you get the answer for both left and right, what you want to do is take the answer that you have between left and right plus the current node you're on, compare it to the global answer. If it's better than the global answer, you update it. And of course, in the DFS, you return the value of your children plus yourself. Okay? So, this is our tree, 1, 2, 3, 4. In step 1, okay? When you are at node number 1, you're making DFS call to your left child, node 2. DFS call to your right child, node 4, right? Left child call happens first. Now you're at node 2. Node 2 says, let me call my left child at 3. When you get to the left child, you call DFS on your children. Well, you're getting null and null, so return 0 and 0. Then you actually get to this part in node 3, okay? That means my left child is 0, my right child is 0, but I return myself, which is 1. So in node 3, left and right are both 0, but you return to your parent the value of 1. Okay? So at node 2, the left child we just mentioned, which is 3, returns a value of 1. Okay? The right child is returning 0 because it's null. So in this case, the answer gets updated. Where is that happening? That's happening right here, because we just said left child is returning 1, right child is returning 0, and itself is 1. So answer will get updated to 2. Okay? Then you go up. You are at node number 1 in this case. And we know that when you were at 2, okay, it returned the value of 2 to its parent, which is 1. And at 4, you return the value of itself to the parent. So at node number 1, you're going to update this again, the answer, because left child is 2, right child is 1, itself is 1, so final answer is 4 for number of nodes. Down here, when you finally return, you will subtract 1. Okay? So part of the original problem statement says the longest path might not traverse through the root node. So let's take a look at what that might look like. So suppose you have here 6, right? Then you have 7, 8, 9, 10, 11. So where is the diameter? Well, the diameter starts here. 1, 2, 3, 4, 5, 6, 7. So in the longest path, it has 7 nodes. So diameter equals 6. It does not run through the root, right? Because if you want to run through the root, what do you get? You get 1, 2, 3, 4, 5, 6. So actually in this case, they are the same because I did not write enough nodes. So if you actually had another node here, I suppose that would make our example work. Okay, but you get the idea. You can see that if you have a tree here, a subtree here in blue, it could represent the diameter, while the diameter does not run through the root. Sorry, this ad hoc example was not exactly right, but I think the coloring scheme gives you an idea what to look for. Okay, and once again, that is Leetcode 543, diameter of a binary tree. It is a technique for this is DFS, right? Something to always think about when you're doing these problems. And I would try to see if you can memorize this type of solution because it takes very few lines of code and it uses DFS, which is very common. And then it'll be time to look at more difficult DFS problems. Okay, thank you.